Welcome back, guys. Basically, we were discussing the difference between wave number and the frequencies. Basically, it is noted and observed that the spectra observed by using the plots of micrometers are very different in appearance from those plotted in per centimeters. Band intensities can be expressed either as transmittance or absorbance. Transmittance basically is the ratio of the radiant power transmitted by a sample to the radiant power of incident on the sample. The power of radiation transmitted by a sample through the power of radiation incident on that sample. And absorbance, which is denoted by capital A, is the logarithm to the base 10 of the reciprocal of transmittance. And the formula for absorbance is written on the whiteboard. Usually, organic chemists report intensity in semi-quantitative terms like strong and use the word S, and then denote medium with M and weak with W. There are two types of molecular vibrations, that is stretching and bending. Stretching vibration basically is an arrhythmical movement along the bond axis such that the interatomic distance is either increasing or decreasing, whereas bending vibration may consist of a change in bond angle between bonds with the common atom or the movement of the group of atoms with respect to the remainder of the molecule without movement of the atoms in the group with respect to one another. For example, there are many examples like twisting, rocking, or torsional vibrations involve a change in bond angles with reference to the set of coordinates arbitrarily set up within the molecule. Only those vibrations that result in a rhythmical change in the dipole moment of the molecule are observed in IR. That is the main point, as we are concerned here only with IR. So, only those vibrations that result in a rhythmical change in the dipole moment of the molecule are observed. The alternating electric field produced by the changing charge distribution accompanying a vibration couples the molecule vibration with the oscillating electric current of the electromagnetic radiation. A molecule has many degrees of freedom as the total degrees of freedom of its individual atoms. Each atom has 3 degrees of freedom corresponding to the Cartesian coordinates that are x, y, z, necessary to describe its position relative to the other atoms in a molecule. A molecule, for example, of n atoms therefore has 3n degrees of freedom. For non-linear molecules, 3 degrees of freedom describe rotation and 3 describe translation. The remaining 3 and minus 6 degrees of freedom are vibrational degrees of freedom or fundamental vibrations. Linear molecules, however, have 3 and minus 5 vibrational degrees of freedom, for only 2 degrees of freedom are required to describe rotation. Fundamental vibrations involve no change in the center of gravity of the molecule. The 3 fundamental vibrations of the linear triatomic water molecule are depicted as you can see that you can observe the very close spacing of the interacting of coupled asymmetric and symmetric stretching compared with the far removed cis-ring mode. I will draw here. You all know the structure of water molecule basically, and here you can observe the symmetrical and asymmetrical and cis-ring stretching between the OH bond of water molecule. In first diagram here, symmetrical stretching is shown, and in second one, where the frequency is 3756 per centimeters, asymmetric stretching is shown, and in the last diagram you can observe the cis-ring movement, that is basically changing the bond angle between two OH molecules.